Hello everyone. In this video, I'm going to talk about lines and planes in space. Firstly, I'm going to talk about lines. In vector functions, we can view a line as being traced out by the tip of a vector. In this graph, we can say that line L is traced out by the tip of vector R. But what determines vector R? That is what we need to determine the line. So as we can see from this graph that vector r equals to vector r0 plus rd. So r0 and rd determines vector r. In this case, r0 is a fixed vector. It is determined by a fixed point on line L. And in this case, the fixed point is x0, y0, z0. And vector rd is the direction vector. The direction vector shows how the x, y, z coordinate of each point of the line changes. So we can describe a line in two ways. The first way is parametric equation, and the second one is symmetric equation. So in parametric equation, we need to find a parameter. So I assume that the parameter is t. In this case, we can express the x, y, z component of r. So the x component of r equals to x0 plus x minus x0 times t, and y equals to y0 plus y minus y0 times t, z equals to z0 plus z minus z0 times t. And here, x minus x0 is A, and y minus y0 is B, z minus z0 is C. So A, B, C is the x, y, z component of the direction vector. So we can simply write vector r as this one. So it equals to x0 plus at, y0 plus bt, and z0 plus ct. And in symmetric equation, we can just change these parametric equation in this way. So x minus x0 over a equals t, and t also equals to y minus y0 over b, and z minus z0 over c. So we can just simply write this as x minus x0 over a equals to y minus y0 over b equals to z minus z0 over c. And in this case, the denominator are the x, y, z component of the direction vector. Now, I'm going to talk about the plane. So what we need to determine a plane? Well, we need a normal vector of the plane. Once we find a normal vector of the plane, all the vectors in the plane are perpendicular to the normal vector, and different planes have different normal vector. Thus, we can determine the plane uniquely for the normal vector. So, the answer of this question is normal vector of the plane. And how can we find the equation of the plane? Well, the principle behind the function of a plane is that the dot product between two perpendicular vectors is 0. In this case, these two vectors are the normal vector A, B, C, and the plane and the vector on the plane, that is this pink vector. So a plane can be viewed as being traced out by a tip of a vector, and this vector is xyz in this graph. We can set the normal vector n at the tip of this vector, and next, we can find another known vector determined by a known point on the plane, x0, y0, z0. So any vector on the plane can be expressed as x minus x0, y minus y0, and z minus z0. Now we can take the dot product of normal vector and the vector on the plane. So it becomes ABC dot x minus x0, y minus y0, z minus z0 equals 0. And this becomes a times x minus x0 plus b times y minus y0 plus c times z minus z0 equals 0. Well, we can also write this equation in another way. That is ax plus by plus cz plus d is 0. In this case, d is a constant, and it equals to minus ax0 minus by0 minus cz0. So this equation is the linear equation of a plane.